So we are here with three wonderful students from the Catholic University of America talking about one of the projects that they work on for this semester, which I find fascinating just to think about what they did and why the elements that they use for this project is very exciting. So I wanted to share with everybody. And here we have three of the team that work in a LEGO 3D bioprinter. I mean, it just blows my mind to just think of could be a bioprinter made of Lego, which I love. I mean, I love Legos, and I couldn't imagine that you could do that. But we will see it more detail in a second. But first, let's meet the team. We have here three of them. It was a team of four. And my first question for the three of you in here, we will go ladies first to talk about what are you studying, what is your engineering field, and also why did you decide to go for that career?
Yeah, so hi, my name is Allison. I'm a computer science major here at Catholic University, and I wanted to study computer science and this type of engineering because I've always loved technology and being able to figure out how it works and how to apply it to certain things. But I wanted the flexibility of still learning and growing post-graduation and not being bogged down into one specific job. Because I can go the software route, I can go hard, like IT, like potentially hardware, depending on the training I get. So I liked the options and the flexibility it provided me for my career. So that's why I wanted to study something as flexible and as a little bit of everything as the computer science curriculum is here at Catholic.
Wonderful. Yes, you are right. I mean, it is a very important field. So now let's move with Eric. If you please introduce yourself.
Right. Hi, I'm Eric Corzine. I'm also a computer science major. I want to study computer science because I've always had interest in programming and technology ever since I was really young. Like I always wanted to make games and such when I was a kid, and I slowly started building up to that throughout schools, and then it got to the point where okay, now let's take classes, and it does still interest me very greatly. And I think it has a very open field to me, and as Allison said, this field is very flexible. I can do a whole lot of fields like software engineering, AI, IT technology, all that fun stuff.
Yeah,
Yeah.
that's great. So, and then we go last with we have Chase.
So my name is Chase. I'm a fourth year biomedical engineering student. Ever since I was young, I've always been into things with engines, so like cars and stuff. It was around high school where I learned about medicine and engineering and how they can be kind of like bound together. So then when I got to Catholic and I saw biomedical engineering as an option, it was a no-brainer.
Yeah, yeah. Actually, I learned recently about biomedical engineering, and I'm amazed of all the wonderful things that you can do. And I think that probably is also uh, the the focus of your project, right? So, how did you decide to work on this project?
Yeah, so how it works is that the first day of class, so literally the very end of August, our instructors for senior design sent us a whole list of I think it started with 25 potential projects, and they had the advisors read a little bit about the project, what type of work it was, and what disciplines of engineering they thought would work best for it, what skills worked for it, so that you weren't totally jumping into something totally unknown. And then from there, we filled out a form with what skills we had, what our major was, how this could apply, and we ranked our top three preferences. For me personally, I wanted to do this project because I've loved Lego since I was a little kid, but also because I thought it was such an interesting concept to use something like Legos to actually help people. And I have a very personal connection. Like my mom has problems with her knee and she will need a full knee replacement one day. And she gets these gel injections every few months to try and mitigate it and delay the process. So
Mm.
when I read the description about the demonstrating the feasibility of artificial replacement cartilage, I really thought, wow, this could be something that could help people like my mom. So I really wanted to see, okay, let's use my love of Legos and my programming abilities to see if I can do something that can help people in the real world.
This project, I think that it has also the possibility to be developed for countries maybe that they don't have resources, right? So that was behind the design, the project that you choose to create something that was low budget, high return.
Yeah, so basically, our advisor, Dr. Wilson, when he came up with this project, he had seen a group that had used a similar idea of using LEGO Mindstorm to make a bioprinter for artificial skin grafts. And his wife had actually just had a knee replacement and that the recovery process is very long, very painful, and it was a very invasive surgery. So he thought of how he could combine his like background in like ceramics engineering and this project, because one Mindstorm kit costs around $200. Whereas
Wow.
opposed to like a normal bioprinter and a normal 3D printer, you're paying upwards of thousands of dollars for a good quality one. So this significantly reduces the cost, and with the nature of Legos, it's easily modifiable, easily fixable. Like the pieces themselves don't break, they'll just disconnect from each other, which is such an easy fix and can really help to make it a more long-standing medical device you can take it apart and rebuild it. Like if we have to transport it to another country, you can
Yeah.
just disassemble what you need and reassemble, and it'll work just as well anywhere in the world.
Yes, definitely. So, well, we are going to have more of a conversation, but why you don't show us the give us a better look of the bioprinter?
There we go.
It looks like a spaceship. So, well, no, it looks,
It does.
it looks like a printer, but I mean, it is very, very cool. So you print in the top, just as a regular printer.
Pretty much, yeah. So we actually,
And
our
then,
final print bed design, this material is actually called Plastruct. It's funny enough, I found it in my dad's hobby closet. It's used for like different like 3D modeling, and it's like a very thin but still sturdy, like flexible piece of plastic, and that's like our print bed. So that's where we're dispensing our material onto. And it's two motors. Actually, it's one motor that moves the actual Plastruct, and then one that moves the print head, almost like your inkjet printer at home.
ah, okay, yes, that's really very, very smart. So how long did it take you to, well, let me go back a little. You had to plan the how you were going to put this together, or do you have already a kind of idea of the pre-design for this printer?
We started fully from scratch. Where
Wow.
a lot of other senior design groups, it'll be like annual projects, like a group will compete in the steel bridge competition, or they'll do outside groups will sponsor a project, like 26 Technologies normally sponsors a project or two for a lot of our computer software, computer engineering, computer science students. But ours was a brand new project. We had no stakeholders. It really was just a brainchild of Dr. Wilson, and it was our job to bring his idea to life. I'm very happy that we did. It was a lot of hard work. It was a lot of research, a lot of YouTube videos of people using Lego for the most random but interesting things.
So in here you both are computer engineering, and then you have the one person or for bioengineering. So how do you divide the work to be able to come up with this design?
Yeah, a lot of it was Chase doing, like, when it came to working on like the material and different ways we could improve it, like actually our final version of it, we're actually kind of making our own bio ink, because we're getting closer to an actual like biocompatible material. So when it came to a lot of like the more technical aspects of it, Chase kind of handled that. Where for general design, it really was a collaborative effort. I know I did most of the like coding only because with the environment that the coding is in, you can't really share files with other people. But when it came to like the logic of the code, we all talked about like, okay, this should do this thing. These two functions need to run in parallel with each other. So it really was everyone just contributed what they could, and we just, where people could shine and highlight their specific engineering experiences, we did. But this really was a bonding experience of working from nothing to an actual bioprinter.
So Chase, tell me, so it is this biomaterial something that you can find easily, or where do you get it?
So our biomaterial, it's called Clayper. It's kind of like Allison was saying, Dr. Wilson's like brainchild. You can't really find it anywhere because it's so special. Um, but the ingredients we use to make it, you can get at the local store. It's
Ah, yeah.
yeah, clay, cellulose, and Elmer's glue. So
The whole purpose of our project was technically just to demonstrate the feasibility. Like the clay
Mm-hmm.
material is not meant to go in the body. It was just so we
Mm-hmm.
could see if we could print something that could be dried into a sheet and folded like origami.
it's
So it's
pretty
something that it is not difficult to envision for someone to be able to do.
Yeah,
correct,
exactly.
yes.
Just combining the right things. No, that's super cool. And it was, I mean, I assume that bioengineering has to very important to how you combine all these elements to create that ink kind of. And what was your role, Eric, in this project? I mean, what were you focused mostly in?
I was mostly just all over the place. I was helping out with mostly just building the system. I mainly designed and built like the current working version we have right now of our syringe pump.
And let me ask you, what is the background of Paul?
Yes, he is a mechanical engineer.
That was the other aspect, right? To
Yes, and he was able to help us make our CAD model of the system so that we could, go from not just a sketch, but to something that we can actually see on the computer and measure it a lot more accurately and directly.
And did it work as you originally planned, or you have to
Oh,
to
it did not work
try
because
error?
we went through a lot of prototypes. Yes,
And
it was.
how long did it take to?
We started building around, I'd say, January. Yes, yeah, we started building around January, and then we kind of have it right now to the point where it's basically kind of where we want it to be, right?
And do you have to create documentation just to the steps, like in the Legos, for example, that you get the little book how to
We
do
didn't
it?
have we didn't have to. This is very much we would find a design for something else that inspired us. And then based on just like one angle of one photo, we would try and reconstruct it. I think that's where Eric really did
Yeah,
come in clutch,
yeah.
so to
Mhm.
speak. That for the newer design of the syringe pump, we had one photo of one angle of it, and you can only see the front. And he was able to just engineer it from there and build the entire thing from just that one kind of blurry image, which was really impressive. So we don't
Mhm.
have an exact thing. A lot of it was, hey, this could be a bit stronger. Let's add like two of the Technic pieces together. So we
Mhm.
probably could, but that would require disassembling the whole thing, and we don't want to do that. We worked too hard on this.
So if so you wanted to recreate it, I mean, for sure, probably you can take pictures and figure it out, but it still will require to think, maybe to remember how you did it.
Yeah. And
Yeah, I would say what we did basically, like what Allison was saying, like we had to remix what was already out there, and you can't really find the instructions for this anywhere. Like this is what we created, and I just want to add, like that's the beauty of working with Legos. You're not working with like $5,000 worth of material. You can fail, and you are expected to fail, but you can go back and redesign, and then your next revision will work.
And I think that that's a very important thing, right? To fail and try it again. And at least, as you said, it was not expensive. So you didn't have the pressure of, oh my God, I am wasting tons of money, right?
mhm.
So you mentioned a little at the beginning, Alison, but how important was to have the right people in the team to be able to accomplish the project? The right combination of expertise. For example, I assume if you two computer science would have tried to do it, you will be missing Chase, right? So how important was to have this team?
It was absolutely crucial because I think especially with a brand new project like this, we all really needed good communication, patience, but also a good sense of humor about it because we knew that like at the end of the day, we were really stressed out and really trying to meet all of our deadlines for our like intermittent reports and presentations. It was trying to remind ourselves that like, hey, at the end of the day, we're doing a brand new project. We have no sponsor. and we're playing with Legos. So it really was just having that like group attitude of we are still doing something. Like the other day I was working on our new like bio ink that like could actually be injected with cells and be like really biocompatible. And I was like, wow, we started with a random thought in our professor's head, and now we have a tangible printer that is printing potential viable bio ink that can go into someone's body. And I really was thinking that just keeping that positive mindset throughout the process of even when it got tough, recognizing it was tough and still dealing with those emotions, but knowing that we had 3 other people that knew exactly what we were going through, and that again at the end of the day, we're playing with Legos.
Yeah, that's yes, it's amazing. And what do you plan to take it after? I mean, now that you have something, what are you going to do with that wonderful printer that you created?
Yeah, I think we want to keep it together. And actually, we didn't even need to buy the kits. We're renting them from the school, but no one really uses them anymore. So we want to see if we can keep it together and potentially give it to a group for next year to see if they, and maybe make that a group of more biomed students. Be okay, here's your printer, fully design a biocompatible material that can use this same mechanism and be pumped through a syringe and still be like, and make it more sterile. Just like to see, like, yes, it's like the whole purpose of our project was technically just to demonstrate the feasibility. Like the clay material is not meant to go in the body. It was just so we could see if we could print something that could be dried into a sheet and folded like origami, but we're already like showing like proof that this can be used past that. So I think our goal is we're going to go into the real world and we're going to leave her in Pangborn, and hopefully a group can pick it up and make it like a real thing.
Well, I mean, I hope that that inspired you to take ideas like this to the next level, right? Because I mean, that's has a potential not only to help people, but also to be, I don't know, a good business for you. Yeah, I mean, there are things out there, but I think that it is wonderful that you were able to do this project. I find it really amazing. So I assume that you are very happy with the results and that you got an A plus. Do you know your grade or not
We're
yet?
hoping. As I say, we still need to get the grades for our final poster, our final presentation, and our like final report on documenting everything from August till now.
And is that report going to be published at the university, or it is just your professor is going to have it? I think that it would be very interesting to see your experience in this kind of project.
Yeah, I think for right now it just goes to our professor, but I mean,
if we wanted to publish, it's definitely gonna need a lot more work than what we currently have. But if we want to go down that alley, we can.
I think we can always send you a copy, Dr. Diaz, if you really want to read it and see.
No, yes, I think that it would be a very good idea, and more than anything, recognizing the work that you did, and actually you innovated with this, which is a wonderful thing to highlight that. So, is there anything that you want to add regarding this project that you think that I missed asking you?
We can talk about, I guess, the more close future steps. So, we've been working with Dr. Rob and Dr. Wilson on a new bioink. So these are called petri dishes. These are sterile, so cells can like grow on here. So what we're doing is we're taking calcium chloride and an alginate, and when the alginate hits the calcium chloride, it gels instantly. So the important thing about that is we can make a kind of like a graft, and we can actually put cells on that graft to actually make a living culture, I guess you
Yeah.
Something that you really can use.
Yeah, something that could actually go inside someone's body and not like automatically be rejected by by their body.
And does it have to have a certain consistency that you need to be able to use it as a bio ink for your printer?
I mean, with the way that our syringe pump works and with the motor, it's as long as it's not insanely thick, it does work well. Like I think our clay material was much thicker because I was playing on with the Alginate yesterday, and it was still gelatinous, almost like a slightly watered down Jello, but it was still thinner than the Clayper, and we were able to dispense the Clayper using the system. So it is. I think it'll be very hard to come by a material that is thicker than the Clayper, but it is still liquid enough that you would even think about trying to push it through a syringe pump.
And what about sterilizing it for making something that you can safely put in the body?
The way that we use it, it's like literally just a syringe, and obviously you swap out the syringe, and we just have, I think it's around a 20-inch tube that connects the end of the syringe to the nozzle, and the nozzle is just a classic chemical like pipette tip. So you can get those sterile as well, and you just change out the tube every time because the Legos will never touch the inside of anything.
Okay.
And with the Petri dish, instead of dispensing the material right onto the plastruct, and the code is honestly the same with the size of it. And instead we would just print it into the Petri dish. So that's how it can stay sterile throughout. It's just making sure that we swap out the nozzle, the syringe, and the tube every time. But again, those materials are incredibly cheap. I think we got a 12-pack of 60 milliliter syringes for around $10.
Oh.
So again, it's things like this that the base system of it is still very inexpensive, but even like making it this sterile thing is still lower cost than what else you would find on the market currently.
Yes, it's really very affordable. And you're chasing your biomedical training. Are you going to try to continue creating this material to develop it probably for something viable to use with the printer?
I think Dr. Rob's lab is working on a more
that.
advanced bioprinter. He was the one that actually recommended the calcium chloride and the alginate. So it definitely is possible and feasible, and there is like research out on it today. So
This lab is at the university?
yes,
Okay, so it is part of the biomedical engineering labs?
yes. So Dr. Rob is actually our department chair. He actually works on bioprinters. I've been to his lab. He has a full scale, similar to ours, but a little more advanced, a little more expensive
little?
too. Yeah. It uses a really cool mechanism. It's somewhat extrusion based, but there's another part of it which allows it to cure stuff. So really
Okay.
interesting.
And even if you use Legos in this, something that is very affordable, by using Legos, it provides the opportunity, I don't know, someone that does machine coding or things like that, to create parts, to have the idea how to create it in a cheap way. Maybe not Legos, but even with something different, right?
Absolutely. And who knows, and like depending on what the need is, you could do mostly Lego and then see if you get a mechanical engineer or someone to potentially 3D print a new custom piece. Because the good thing about these Legos is that they're very well documented and they all have very uniform like sizes for their gaps in between, like how big like the diameter is in like the holes where you put the connecting pieces. So this does open the door to like, okay, have it mostly Lego based, but if you really need to fit this one angle in a super particular way, you could use a standard 3D printer and just do one small build. The filament is pretty inexpensive, and you could print a custom piece if you needed to advance this more.
Yeah, and I can imagine the application also for space exploration. You can send something like that to put in space and just put it together even in there. I mean, you don't need to bring the whole printer, right?
Yeah, exactly.
Okay, can we see it again just to have a last shot of it? And
of course.
Yeah, no, Super, super cool. I love what you did. And actually, the important thing is the application and in this aspect of biomedical engineering and highlight your teamwork, the experience, the enthusiasm, the innovation heart that you all have. That's a wonderful thing. So thank you very much for giving me this opportunity to talk to you and see that beautiful Lego creation. Just very, 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 very important work that you did in here, and I'm very happy to be a witness of what you did.
Thank you so much for the opportunity to talk to you. It's so great to, see how something that we do for a course credit could really impact the real world.
Yes, yes, definitely.